Hi guys, if you get an object, you always wonder where it is. Where is the object heading towards? How fast does the object move? The answer lies inside position, velocity, and acceleration. Let us talk about position, velocity, and acceleration. First and foremost, what is position? Position is basically where an object is in space or the location of an object. We usually express position to a reference point or to an axis. This can be also shown from a distance from a reference point to another point with the relevant units embedded in it. Next up, what is velocity? The velocity is the change in position per unit time.
The velocity is defined as the displacement per unit time. So if we assume this particular Formula 1 car takes 1 second to cover a distance of 10 meters, the velocity of the car would be 10 meters per second in this particular direction.
What is acceleration? The acceleration is defined to be the change in velocity per unit time.
The acceleration is defined as the change in velocity per unit time. So if we assume the Formula 1 car speeds up to 10 meters per second in a time of 2 seconds, the acceleration of the Formula 1 car in this direction would be 5 meters per second.
So guys, that is a briefing on position, velocity and acceleration. Now let us consider a deep review on these particular terms. When we hear the word position, what two words comes to your mind at first? It is distance and displacement. The distance is a scalar quantity which has a magnitude only, whereas displacement is a vector quantity which has a magnitude and a particular direction. The video on scalars and vectors is attached in the description for better understanding. Hope you guys click on the link below to go to the video.
Two friends, Simon and John, are closer to each other in this particular starting point. Both of them want to reach towards the door which is far away from them. Simon, however, opts to take the path along this line, so he would travel 50 meters. Whereas John, however, would travel towards the tree which is 40 meters away from him, and also he would travel 30 meters straight up towards the door. So the distance that John would cover would be 40 plus 30, that would be equal to 70 meters, whereas Simon covers only a distance of 50 meters. So guys, here we can define the two terms distance and displacement. The distance is a scalar and displacement is a vector. Simon would travel 50 meters towards the door, whereas John would travel 70 meters in his complete journey. The displacement of both of them would be 50 meters, as the shortest distance from the point of starting of both of them towards the end point, which is the door, is 50 meters. So we can define that distance is a scalar and displacement is a vector. The displacement is a vector, so we need to consider the angle as well because it has a specific direction embedded in it. So the angle here we use was theta. So tan theta in this case would be 30 over 40. So we would obtain that theta is equal to tan inverse 3 over 4, which will also give that theta is equal to 36 degrees and 52 minutes. So guys, what's a vector and what's a scalar when defined with displacement and distance? Displacement is a vector which has a magnitude in a particular direction, whereas distance is just a scalar with a magnitude. That is about distance and displacement.
Let us now discuss about velocity. So what is velocity?
The velocity is a vector, whereas speed is a scalar. the velocity has a magnitude and a particular direction, thereby it is a vector, whereas speed has got a magnitude only, thereby it is a scalar. The average velocity is termed as the displacement per unit time, whereas the average speed is the distance per unit time. We can see a clear difference in between velocity and speed, because velocity is a vector and speed is a scalar.
Let us now discuss about acceleration. So guys, what is acceleration?
The acceleration is a vector. This is because the acceleration has a direction embedded in it. The acceleration is also termed as the change of velocity per particular time, whereas deceleration is the negative of the acceleration. If we assume the Formula 1 car travels in this particular direction, changing its velocity, whereas it is increasing its velocity, we can term it as an acceleration. If there would be an instant that this particular Formula 1 car suddenly brakes, there would be an acceleration in the opposite direction. This is termed as a deceleration. So guys, that is about acceleration and deceleration.
We hope that you guys understood the terms position, velocity and acceleration as we defined each of these terms. Hope you guys enjoyed today's video. Have a nice day.